So in order to solve this problem, we're going to have to relate this new force, the force of gravity within the Earth's surface, to a force we're more familiar with, this Hooke's law force, the force exerted by a spring. So we know that with springs, the period is equal to 2 pi times the square root of the mass over the spring constant k. But in this problem, we don't have a spring constant, and we don't have a value for k. But you'll note that by comparing our two equations here, we can actually find something in this equation that looks a lot like k. In this equation, the role of k is played by little g times m over the radius of the Earth. So we can call this new collection of constants kg, where kg stands for our new spring constant with respect to this gravitational force. So now we can rewrite our equation for the force of gravity within the Earth as F equals kg times the radius. And now this equation looks exactly like this equation. And we can tell what the value of k in this equation for period should be. We should just use our kg value. Okay, so now I can use this value of kg, gm over re, as the value of k in my period equation, like so. And quite pleasantly, the mass terms here cancel. And this gives me this final equation for the period of a person oscillating through the center of the Earth, that the period is equal to 2 pi times the square root of g over the radius of the Earth. And I know all the values here, and plugging in all those numbers, I find that the period of this oscillation is equal to 83.8 minutes. If you are able to get this value, congratulations.